with Kettering University, and this is Kettering's fuel cell and reformer system. The system was put together as a collaborative effort as part of the Center of Energy Excellence, which consists of funding from the U.S. Department of Energy. We are working with the Flint Wastewater Treatment Plant, Swedish Biogas International, which is on campus, and Kettering University. This system consists of a Global Energy Innovations Auxiliary Power Unit, an APU, which consists of a fuel cell system, the balance of plant, and a battery system. It also consists of the reformer, which is purchased from HTPEMFuelCell, a German company. This system, in simple, takes the methane or biogas and then ultimately converts it into electrical output. This is the HTPEMFuelCell reformer. In short, a reformer is a device that changes methane, CH4, into hydrogen using a catalyst in the presence of high temperatures. On the reformer, there is the methane inlet or biogas. This is ignited until the burner reaches approximately 800 degrees centigrade, at which point the gas is auto-ignited, so the spark plug turns off. This process is used to heat a catalyst inside of the reformer. Once the catalyst reaches 700 degrees C, the methane or biogas and steam are plumbed through the catalyst, and this is converted to approximately 80% hydrogen and 20% carbon dioxide. This hydrogen goes into the APU. Once the APU uses the hydrogen, excess hydrogen flows out of the fuel cell and is plumbed back into the burner on the reformer. This is used to reduce the usage of methane in heating the catalyst. The burner exhaust is plumbed from the reformer outside.
GEI uses National Instruments hardware and software to develop a unique data acquisition system. This National Instruments control panel controls the fuel cell and the reformer, as well as monitoring for errors and timing and control.
Hello, I'm Jeremy Ganida, and I'm standing next to the APU that was purchased as part of our biogas project. And this APU uses fuel cell technology, and a fuel cell technology is a membrane. And the membrane, you flow hydrogen across one side, and as you do, the hydrogen atom gives up its electron. This electron is collected on electrode. The electrode flows the electrons as electricity through your load, so your flashlight or power supply or whatever. And as that electron comes back up to the other side, it meets up with your hydrogen proton. The hydrogen proton then combines with oxygen and the electron to form water. So water is your byproduct, and the membrane itself heats up. So you also have heat as a byproduct, and then obviously electricity that you're trying to get. So this is one membrane inside the fuel cell, and if you take another one, stack it right next to it, and another, just like flashlights, you stack a bunch of batteries to get a higher voltage. You can do that with a fuel cell, and create a fuel cell stack to make a larger power supply. And that's what we have inside this APU. It's a fuel cell device that uses hydrogen and produces water and heat as a byproduct to make electricity. As I mentioned earlier, we have an APU here that is of fuel cell technology. The unique thing about this fuel cell is that it's a high temp PEM. The high temp PEM runs at a much higher temperature than regular PEM, and the benefits of that is that you can use a dirtier hydrogen source. So an 80% hydrogen feed would be just fine to run this fuel cell. We have a 40-cell stack and our balance of plant that uses a C-reel controlling device to warm up the unit before operation. It gets its power to warm up from this battery stack. This is a 40 amp hour battery pack that gives us about 2 kilowatts of power, so that we have enough energy storage to bring this up to temperature before operation. Controlling all of this is the power electronics. They take the battery power, feed it to the fuel cell unit, and then recharge the battery afterwards from the output of the fuel cell unit. It also has a 3-channel output that is programmable for different DC outputs. Currently we have it connected to these bank of lights, so that if I just turn on these lights, we can run off the fuel cell, and the fuel cell is getting its energy from the biogas from Flint Wastewater Treatment Plant through our reformer.
As it has been shown, this fuel cell and reformer system is a means of producing electricity from biogas for use in a variety of applications. This project would not have been possible without the support from the Michigan Economic Development Corporation, the U.S. Department of Energy, the Flint Wastewater Treatment Plant, the technologies of Global Energy Innovations and WS Reformer, and the Kettering faculty Brenda Lemke and Dr. Ahmad Momomed.